In meteorology, we generally talk about things in terms of UTC, but a lot of data and people in general like to talk in their local time zone. We also just had a time change in many parts of the US, and we're going to see how we can deal with time zones and time changes in this week's MetPy Monday. Hello, I'm John Lehman, a software engineer for NSF Unidata. This week I want to continue looking at some date-time things. We've talked about naive date-time objects and how we can start to think about time zone information being added in. But this week I want to go a little bit more in depth into time zones and show you one interesting case that I found where it doesn't necessarily have the behavior you expect. So we're going to start out with from datetime, import datetime. And recently we had a severe weather event move through my area. In fact, there's a tornado relatively close to my recording location. So I'm going to put in the approximate time of that event, November 4th of this year at 16 hours 9 minutes. And that was a local time, so 4:09 in the afternoon. If I look at my event time and look at the ZoneInfo object, we see that it's none. I haven't specified any time zone information. Now we've talked about PyTZ a little bit, and PyTZ, it is still a project that is active, but it is in maintenance mode. So it's not deprecated, but it's actually, if you're using Python 3.9 or later, recommended that we use the built-in ZoneInfo. So this week I'm going to show you how to use that. Though you'll still see PyTZ in many things that are still out there. So from ZoneInfo, I'm going to import ZoneInfo and available time zones. Don't forget to use tab completion and save yourself keystrokes. So how do you know what time zone you're in, or what at least Python is going to call it? We can use the available time zones method here. And look, we get a list of all the time zones that Python knows about. And in my case, I'm going to look up in America, and probably the closest to me is going to be America, Chicago. So I'm going to copy that. I'm going to click there to collapse that cell. And now I'm going to define my time zone, which is going to be an instance of ZoneInfo with America, Chicago. So now I want to put that information in my event time. So event time is going to be equal to event time.replace TZInfo equals my TZ. Now you may remember the replace method on a datetime object lets you do things like change the year, month, day, hour, minute, or second. In fact, I use it quite a bit when I want to truncate minute and second information and just get a year, month, day, hour, or maybe I just want the year, month, day and leave everything else at zeros. This is a great way to do that, but it doesn't only work on those parts of the datetime object. It works on all parts of the datetime object, and time zone info is one of those things. So now if I look at event time, we see that I still have my datetime object, but I have that additional time zone information key. Now this doesn't show like PyTZ would show you that it was, in my case, minus a day plus, let's say, 18 hours. And in this case, it just tells you what the key that you're using is, America, Chicago, which is fine. So how do we get that event time in UTC? If I want to go pull observations from a radar station nearby, or I want to pull a sounding from near when this event happened, how can I do that? I'm going to create a variable called event time UTC. Is my event time dot as time zone, and then we specify what time zone we would like, In this case, it is a instance of ZoneInfo UTC. If we look at event time UTC, now we see that that is 22 hours UTC. So that's 6 hours ahead, which is the correct offset for when this event occurred. What about taking subtractions of time? We know from working with Pint in the unit library that temperatures are one of those funny things when you're doing subtractions and additions of, and times can be a little bit funny as well, as we'll see. But let's see what happens if we have different time zones and we're doing math on them. So I'm going to take the event time UTC minus the event time. Now, we just established that they are the same time in terms of absolute time on the planet, but that they are several hours apart because of the time zone difference. Well, we get a time delta back of 0. So in this case, it's smart enough to convert those time zones and give us a correct answer if they're at the same time. Now, let's double check that. It's always nice with Python when you're exploring behavior. Okay, this is one case where it works. Let's look at another case. So I'm going to create a variable called 1 hour later UTC, and it's going to be an instance of date time, and it's going to be the same day, but it's going to be exactly 1 hour later. I'll go ahead and create it with ZoneInfo specifying that it is a UTC. Now if I take 1 hour later minus my event time, we see that it says they are an hour apart. So the time zone conversion is happening correctly. What if I do it the other way? Event time minus 1 hour later. We'll see that it's minus a day and then forward 82,800 seconds. So it's telling us that it is 3,600 seconds earlier. So that all seems to work well. One interesting thing, now that we're dealing with time zones a lot, is I wanted to point out a formatting character that you may not be aware of or used to using, though I've found it very helpful now that I'm not using naive date time objects for everything, is the %Z. Oh, got a typo there. And that shows it Central Standard Time. So this shows the time zone if your date time object has been localized to a time zone. Again, pretty handy. Okay, so now I want to look at another case where we see why you should always verify that Python does what you expect it to do, especially when you're going to feed it a bunch of your research data and depend on it to do things for you. And that is the time change between daylight savings time and standard time that just happened here in the US. So we roll our clocks back at 2 o'clock in the morning local time this year on November 3rd. So I was curious what would happen if we looked at an ambiguous time. And if we look at the ambiguous time of November 3rd at 1:30 in the morning. So why is that time ambiguous? It's ambiguous because we experienced it twice. We had 1:30 in the morning, then the clock hit 2 a.m., and we rolled the clock backwards an hour, which means that we were back at 1 a.m. and we had the second 1:30 of our day. Okay, so luckily Python does have a way to deal with this. The first instance is ambiguous time. I'm going to put time zone info in because we haven't done that yet. We're just going to use my time zone, my local time zone. And if we look at that, we see America, Chicago, 1:30 in the morning. So all is good. Now we can do the second instance. So that's my ambiguous time. I'm going to call .replace time zone info equals my time zone. And now I'm going to say fold equals 1. If I look at the second instance, well, it looks the same except for it says fold equals 1 now. But let's look a little more closely. The first instance, UTC offset, and the second instance, UTC offset, are indeed different. So why are they different? Because it's the second one that we experienced. The difference between those times should be 1 hour, right? We experienced an hour of life in between the first and the second event. So if I take let's do the second instance since that's later in time actually, and subtract the first instance. We get a time delta of 0. Interesting. So now let's take the second instance, UTC, is going to be second instance as time zone, ZoneInfo, UTC. The first instance, UTC, is going to be first instance as time zone, ZoneInfo, UTC. And now I take the second instance, UTC, minus the first instance, UTC, and we get a time delta of 3,600 seconds, or an hour, which is what we expect. So to me, this was a very non-intuitive behavior, as to me, the point of knowing time zones in Python is so we don't have to worry about it doing math like this. But as it turns out, if you don't first convert these to UTC and then do your math, interesting things can happen because of the standard to daylight transition. So doing a little bit of reading on this and why it is so brings us to, in the CPython repository, issue 112,638, opened about a year ago, that describes this exact issue. And the consensus was, based on how the PEP was written, this is the behavior that was intended. So everything is working as designed and documented, and the issue was closed. I'm not thrilled with that answer because even though it is working as designed and documented, this could definitely cause issues for you when you're calculating deltas between data sets that involve a daylight savings transition. So going to UTC is always the safest bet, and it is easier to go to UTC with the time zone info attribute than it ever has been before, but there are still some things you have to be careful about if you don't go to UTC in the end. So I hope that you found this little introduction to time zones and some of the quirks of them in Python useful, and I'll see you on next week's MetPy Monday.